first question wants us to add two mixed numbers together. We make these into top-heavy fractions first. So 2 7s is 14, add the 1. 1 4 is 4, and add the 1. We need a common denominator for these, so multiply by 4, multiply by 7. 4 15s gives me 60 over 28. 7 5s gives me 35 over 28, and this works out at 95 over 28. It didn't ask for it in any form, but if you did want to change it, this is also the same as 3 and 11/28. Both answers would be correct. Dividing, we need to change the top-heavy fraction again. So 6/5 divided by 3/4. This is the same as 6/5 multiplied by 4 over 3. 6 times 4 gives us 24. 5 times 3 is 15. It wants it as a mixed number in its simplest form. I can divide both the top and the bottom by 3 to get 8 over 5, and as a mixed number that is 1 3/5. Question 2. As a product of prime factors, we want to find the numbers that multiply and are the prime factors. So 168 we can split into 2 multiplied by 84. We can split this into 2 multiplied by 42. 2 and 21, and 21 can be split into 3 and 7. As a product of prime factors, this is 2 times 2 times 2 times 3 times 7, or 2 cubed times 3 times 7. Both answers would be correct. The highest common factor of these, if I work out my prime factors of 180, which would be 2 times 90, 3 times 30, 3 times 10, and 2 times 5. My prime factors of 180 are 2 times 2 times 3 times 3 times 5. My highest common factor is what's in common between those two. So in common between 168 and 180, we have 2 2's in both and we have a 3 in both. Left over in 168 is a 2 and a 7, and left over in 180 is a 3 and a 5. My highest common factor is the numbers in the middle. 2 times 2 is 4, times 3 is 12. The next question is plotting a quadratic. We substitute our values of x into the equation. 1 squared is 1, take away 4 is minus 3. 0 squared is 0, take away 4 is minus 4. Minus 3 squared is 9, take away 4 is 5. We then plot these coordinates. 3, 5, 2, 0, 1, minus 3, 0, minus 4, minus 1, minus 3, minus 2, 0, minus 3, 5. We then connect these up with a smooth curve, which is tricky to do on a laptop. But make sure there's a smooth curve through all of the points. Question 4, expanding the bracket, be careful of the minus in the middle. This is a common exam trick. 3y minus 6, take away 10y, minus 5 times 1 gives us minus 5. Collecting the like terms, we end up with minus 7y, take away 11. Factorising, we have a set of double brackets. This is difference of two squares, x plus 4 and x minus 4. Expand and simplify, 3x squared plus 7x minus 18x and minus 42. Collecting the like terms together, 3x squared minus 11x minus 42. The next question is on standard form. Write 8.2 times 10 to the 5 as an ordinary number. This is multiplying 8.2 by 10 5 times. 1, 2, 3, 4, 5. Changing this into standard form, we'd go 1, 2, 3, 4 backwards, so 3.76 times 10 to the minus 4. For standard form calculations, we're going to do 2.3 divided by 4.6. We're also going to do 10 to the 12 divided by 10 to the 3. 2.3 divided by 4.6, you should be able to see is a half, or 0.5. And then here we subtract our powers to get 10 to the 9. 0.5 times 10 to the 9 is not in standard form. We make 0.5 10 times bigger, so we make 10 to the power of 9 10 times smaller, and your answer is 5 times 10 to the 8. For question 6, we're going to write that x is equal to our reoccurring decimal. That 10x is 2.8181. 100x is 28.1818. And 1000x is 281.8181. What we're looking for is two numbers where our decimal places line up. Our decimal places line up at 10x and at 1000x. They are the same, they both go 8181, reoccurring. So if I subtract 10x away from 1000x, 1000x being 281.8181, and 10x being 2.8181. If I subtract these, I'm going to be left with 900, and 90x is equal to 279, meaning that our reoccurring decimal is 279 divided by 990. This question wanted that in its simplest form. I can divide both the top and the bottom by 9, and this will give me a final answer of 31 over 110. Question 7, the value of 64 to the power of a half is the square root of 64, which is 8. For this question we deal with the negative first, so we have 125 over 8 to the power of 2/3. This is the same as the cube root of 125 over 8 squared, which is 5 over 2 squared, which gives us an answer of 25 over 4. The value of sine 60, this is root 3 over 2. This is something you have to remember, or you can use triangles or a table of values to remember this. Question 9, show that the angle is 135. The angle CDJ is this angle here. We need to prove it is 135. You can't state it's 135 at any point until your final line, otherwise you're using it rather than proving it. We have an octagon. We know the interior angles of an octagon is n minus 2 times 180. So our interior angles is 6 lots of 180. And then we're going to divide that by 8 to find each one. So 6 times 180 divided by 8, which gives us 135. That means each interior angle is 135, and here we have 135 and 135. My next step is having a look at the quadrilateral at the top that goes from A to B to C to D. I know that my quadrilateral adds up to 360, so if I do 360, take away 2 lots of 135, right, that is going to give me 360, take away 270, which is 90. Both of these angles are the same, meaning that these angles are both 45 degrees. I also from there should be able to see that the angle from C to D to A plus the angle from C to D to J has to be 180. So doing 180, take away 45, gives me the answer I'm after of 135 degrees, and that is proven. There were lots of different ways to do this question, some involving exterior angles, but this is the way I would have approached it. Question 10, we have a cuboid. We can tell the volume of the cuboid is less than 900 centimetres cubed. That means that x multiplied by 3x multiplied by 2x is less than 900. If we multiply this together, that means that 6x cubed is less than 900. If I divide by 6, we know that x cubed is less than 150. We can't cube root this because we're on a non-calculator paper, so we have to show that it is less than 150, so less than 5. 5 cubed is 125, 6 cubed is 216. So from here, because x is an integer, we know that x must be less than or equal to 5. You have to justify this. It's not, the cube root of 150 is not 5. Carol runs in a race. This is her speed in metres per second. We want to calculate the acceleration when t is 4. So you must go to t is 4 and draw a tangent as close to the curve as you can. And from here you work out the gradient. Again, as we are on a non-calculator paper, try and make this as nice for yourself as possible. If I go from 3 to 4, that means my difference in x is 1, and then going up, I can see that my difference in y is around about 1.1. Okay, these questions always have some leniency, but the gradient is our acceleration, so we want our difference in y divided by our difference in x, which is 1.1 divided by 1. So that answer would be 1.1. There was leniency in this paper. You would have had answers ranging from between 1.0 to 1.3. Depending on how accurate your tangent is, you'll get different answers for that. Okay, question 12, we have a tangent to a circle. It doesn't give us our coordinates, so we're going to use our equation of our circle to find our coordinates. We don't know what x is, but we do know that y is minus 15, and that's equal to 261. Okay, we're going to solve this to work out what x is. So we're going to do x squared is equal to 261, take away minus 15 squared. This means that x squared is equal to 36, meaning that x is either positive or negative 6. We can see it's in our positive x coordinate, so we know that x is equal to 6. Once we've done this, we know our coordinate is 6 minus 15. I can work out the gradient of my radius. The gradient of the radius is my difference in y from 0 to minus 15, divided by my difference in x from 0 to 6. So my gradient of my radius is minus 5 over 2. That means the gradient of my tangent must be positive 2 over 5. I can then use y is equal to mx plus c to work out what my y-intercept would be. Put the coordinates in. Minus 15 is 2/5 times 6 plus c. This tells me that minus 15 is 12 over 5 plus c. And if I subtract 12 over 5 from both sides, I will find out what c is. 12 over 5 is 2.4, minus 15 take away 2.4 gives us that c is minus 17.4. That leaves us with y is equal to 2/5 x minus 17.4. Question 13, we want to find our cumulative frequencies by adding all of the frequencies. So we get 8, 23, 53, 70, 77 and 80. From here, part A wants us to draw our cumulative frequency graph, and part C wants us to use our graph to estimate a solution for the interquartile range. To plot our graph, we're going to plot the endpoints, so 208, 323, 453, 570, 677, and 780. We then draw a smooth curve through all of these points. And that is our cumulative frequency graph done. It doesn't have to go through 0, it can meet at 100 because the smallest value was 100. Part C, using our graph to find an estimate for the interquartile range. For the interquartile range, we need our upper quartile and we need to subtract our lower quartile. There's a total of 80 people, so our lower quartile is the value we read off from 20, our upper quartile is the value we read off from 60. Okay, so if we read off our values at 60, which is our upper quartile, everyone's will be slightly different, there's some leniency within the question. If we read off the value at 60, we get around about 440. So my upper quartile is around about 440. Our lower quartile is at 20. If I read off my value at 20, I get about 300. So my interquartile range is 140. There was a leniency in the answers of 120 to 160 between there. For question 14, adding fractions, we need a common denominator. So I need to multiply the first fraction by a minus b and multiply the second fraction by b. That will give me a common denominator of b multiplied by a minus b. So we end up with 3a minus b over b lots of a minus b, 2 lots of b over b lots of a minus b, and this gives us a single fraction of 3a minus b plus 2b divided by b a minus b. The questions ask for this in its simplest form, so expanding the bracket we get 3a minus 3b plus 2b divided by b lots of a minus b, and that gives us our answer in its simplest form. Minus 3b plus 2b is minus b, so 3a minus b over b lots of a minus b. Our second question wants to simplify. To simplify, we're going to factorise. It's easier to factorise the denominator for x plus 3 and x minus 3. To factorise the numerator, we know we're going to have 2x and x. We know we're going to have a 3 and a 1, so we can use trial and error or split in the middle to work out that this factorises to 2x minus 1 and plus 3. The x plus 3's cancel out and we're left with a simplified fraction of 2x minus 1 over x minus 3. Question 15. Y is proportional to the square of x. This means we can write y is equal to kx squared. If we substitute in 36 and 3, we can see that 36 is equal to 9k, which means that k is equal to 4. We can then write our proportion equation as y is equal to 4x squared. The question wants to find the value of y when x is 5. We substitute 5 in, so 4 lots of 5 squared. So y is 4 lots of 25, which is 100. Question 16, we have a density and mass question. We know that density is mass divided by volume, and we have two separate alloys. For alloy number 1, for our lead, we know that the mass is 80. We know that the density is 16, and we know that the volume we can work out here. So our volume is going to be our mass divided by our density, 80 divided by 16, which is equal to 5. Our tin is similar. We have a mass of 120. We have a density of 15. So our volume is going to be 120 divided by 15. Okay, 120 divided by 15, you can see is 8. This means that in total we have a mass of 200, and in total our volume is 13. This wants our answer correct to 1 decimal place, which means that we're going to have to do some division. We want to do our density as our mass divided by volume, so 200 divided by 13. 13 into 2 goes 0 times, with 2 left over. 13 into 20 goes once, with 7 left over. We want it to 1 decimal place. We know we're going to have a remainder. 13 into 70 goes 5 times, and it has 5 remainder. 13 into 50 goes 3 times, and whether it's 0.3 or 0.4, we need that extra decimal place. We know 3 13s is 39, so it was 11 left over, and 13 into 110 goes 8 times, and we don't care about the leftover. So the answer is 15.4 grams per centimetre cubed. Rachel takes 2 cards at random. This means she does not replace the cards. We want the probability that there are different letters on the 2 cards. We could work out the probability of A then B, the probability of B then A then C, and so on. This might take a while, so instead we can work out the probability that they are the same and subtract this from 1. So we're going to do 1, take away the probability that they are the same. For them to be the same, I can either take an A and an A. This will be 3/6 multiplied by 2/5, which gives us 6 out of 30. The probability of picking a B and then a B is 2/6 multiplied by 1/5, which is 2 out of 30. And the probability of taking a C and a C, we can see this can't happen because it's 1/6 and then there's none left over, which would just be 0. This means the probability of getting 2 the same is going to be 8 out of 30. 1 take away 8 out of 30 gives us 22 out of 30. Question 18, we need to rationalise the denominator. The first thing we do is expand the brackets at the bottom. So we can see that 3 minus root 2 multiplied by 3 minus root 2 is going to be 9 minus 3 root 2 minus 3 root 2 plus 2. Okay, this means that our fraction is left as 1 plus root 2 over 11 minus 6 root 2. To rationalise the denominator, we need to multiply by the conjugate, so multiply that by 11 plus 6 root 2 over 11 plus 6 root 2. Again, this is 2 sets of double brackets, so 1 11 is 11, 1 and 6 root 2 is 6 root 2, 11 and root 2 is 11 root 2, and root 2 times 6 root 2 is 12. Along the bottom, we know that the middle terms will cancel out, so 11 11s is 121, and 6 root 2 and 6 root 2 gives me minus 72. Okay. This then simplifies to 23 plus 17 root 2 divided by 49. We want this to be in just the form a plus b root 2, This means that A is 23 over 49 and that B is 17 over 49. Question 19 is a vectors question. So part A is express A to B. A to B, we would go from A to O and then from O to B, and this is just minus 3A plus 6B. For part B, we want to prove that OX is 2/5 of OY. We've been told that AX to AB is 1 to 2, so this is a third and this is 2/3. To find O to X is O to A plus A to X. O to A is 3A and A to X is a third of A to B, which we've already worked out as minus 3A plus 6B. If I simplify this, we get 3A minus A plus 2B, which is 2A plus 2B. We now need to work out what O to Y is. To get from O to Y, I can go from O to B and then from B to Y. O to B is 6B and B to Y is 5A minus B. This gives us 5B plus 5A. I can then show that one is 2/5 of the other. I can say that 2/5 of OY is equal to 2/5 of 5B plus 5A, which is equal to 2A plus 2B, and that we can see is O to X. Question 20 is a particularly difficult question, especially for a non-calculator paper. We have a sector of a circle from O to P to Q, and that's split into another sector from O to A to B. We know that this is split in the ratio 3 to 2, so this is 3/5 of the radius, and this up here would be 2/5 of the radius. It tells us straight away that the area of the shaded region is 81 over 2 pi, so we know that 81 over 2 pi is equal to the area of the entire sector, which is 45 360ths of pi times r squared. Take away the smaller sector, which again is 45 360ths of 3/5 of the radius squared times pi. I can simplify this slightly. I'll keep the 81 pi over 2 here. I'm going to factor out the 45 over 360 and the pi, and this is going to give us r squared take away 3/5 r all squared. Okay. This bit in the brackets turns into r squared minus 9/25 r squared, which is 16/25 r squared. So we're left with 81 pi over 2, 45 over 360 is just 1/8, pi multiplied by 16 over 25 r squared. The 1/8 and the 16 can cancel out to give us 81 pi over 2 is equal to 2/25 pi r squared. From here we should be able to see that 81 over 2 is equal to 2/25 r squared. I can then multiply both sides by 2 to give me 81 is equal to 4 over 25 r squared. Trying to solve for r squared now would lead us with quite some big numbers for a non-calculator paper, so we can square root from here. Square rooting both sides give us 9 is equal to 2/5 r squared, and from there we can see that r is equal to 45 over 2, or 22.5. The question wants to work out the perimeter of the shaded region and giving our answer in terms of pi. The perimeter of the shaded region is the length of the arc, 2 lots of 2/5 of the radius, and then the length of the smaller arc. So we know that the length of Q to B and P to A are the same, so I know that the length from Q to B is 2/5 of 45 over 2, which is 9. So Q to B is 9 and P to A is also 9. To work out the lengths of the arc, we're going to have to use pi r squared again. If this area here from A to P is 9 and O to A is 3/5 of our radius, we know that O to A is going to be 9 plus another half of 9. So O to B and O to A are 13.5. To work out the arc length from A to B, which I'll put here in green, we want to do pi times the diameter, and then we want 1/8 of that, as it is just 1/8 of the circle. We know that the diameter is going to be 27, so 27 multiplied by pi times 1/8 just gives us 27 pi over 8. The other arc at the top from P to Q, which I'll put in blue, is the same idea. It's pi multiplied by the diameter multiplied by 1/8. We know that the radius of the whole circle is 45 over 2, so the diameter is 45 times by pi times by 1/8, which gives us 45 pi over 8. If we put all of those things together to give us our total perimeter, we have 2 9s from A to P and B to Q. We also have the arc from A to B, which is 27/8 pi, and we have the arc from P to Q, which is 45/8 pi. Okay, this gives us a perimeter of 18 plus our fraction of pi. 27 plus 45 turns out to be a multiple of 8. This comes out as 72. So 72 divided by 8 is 9. So we're left with 18 plus 9 pi. Okay, that was quite a challenging question for a non-calculator paper. If you found these walkthroughs useful, please do consider subscribing. There will be more walkthroughs and exam tips coming soon. If there's anything you'd like to request, please write it in the comments. It would be lovely to hear from you. Thank you for watching.